All right, so we are talking about trees. Um, trees, fundamental data structure in programming, gets used in all kinds of different things. Probably one of our most common, most useful data structures. So, before I dig in, hit me with some trees questions. What do you want to know about trees? What are you curious about?
Does scoping work the same in trees as it does in regular JavaScript?
Great question. What else?
Do trees like pass information down to the child or the children in the tree?
Outstanding question. What else?
The precedence of binary tree model?
Okay, what else?
Just kind of tagging on the question about the children.
Mm-hmm.
Does it ever pass a generation, or is it always has to go like through one level and the next?
Another outstanding question. What else? Well, this gives us a place to start. So, I think, especially based on the submissions I've seen before, nobody's having a hard time with like this as a concept. Um, I think where the disconnect is happening is between like this as a mental model and then like how trees get used in programming. So let's build out a tree. How about? Okay, so let's do a like a family tree kind of thing. So we're gonna need something to that like makes nodes. So I have a function called like create node, and it's going to take in a person. And then we're also going to want a function that's like add child that takes a person and a child. And so that's probably enough to get us started. So creating a node with a person. So we need, we want to store that data. So like the person, we can pretty much leave that untouched. But the other thing that we really need, and really what makes the tree structure work, is this idea of children. And so when we create a node, we're going to initialize children to an empty array. And so the way this might get called is, let's see, I'll do, see, I'll do my dad as a patriarch on this. And I'll be me. And I'll throw my sister on here. And yeah, let's start there. So, all right, so I have these three objects here. So I could say that the root node is calling like create node, and we'll say that Ken is the root node on this. And then I can call like add child root Kyle and add child root Karen. Oops, I actually need to turn Kyle and Karen into nodes also. I can do those in place though. Let's say like add child create node Kyle, create node Karen. Cool. So this add child is going to take the person that we pass in and their children. This is like a person node. We'll just call it node. So it's going to take in the node, and then dot children is an array. So we can do something like push the child into it. That's it. That's trees in a nutshell. So let's say I like want to play with this a little bit. Actually, I'm going to add just a couple more levels to make it more obvious. So Duncan's one of my kids. And Miles is one of my kids. And Katie is one of my sister's kids. And Megan is one of her kids too. All right, so I can keep doing this. Although, oops, I am going to need to save these first. You'll see why in a second. Oh, actually, you know what? Sorry to thrash on this. I thought of an even better way to do this. For each of these, I'll just wrap them in create node. Yeah, I like that. So and then cool. So this is going to be add Kyle to Ken, add Karen to Ken, add Duncan to Kyle, add Miles to Kyle, add Katie to Karen, add Megan to Karen. All right, cool. So there we go. I built a tree. So if I was using this in a program, I can load up that index.js file. All right, cool. So if I look at Ken, I have all that back. And if I do ken.children, hey, look, it's me and Karen in there. And if I go, all right, ken.children at 0.children, I see Duncan and Miles. That's what a tree looks like in code. Oh, Kyle, but what about the DOM? What about the DOM? So if I grab some element on here, like go somewhere real. And I do something like body, shush. If I do something like bodies document.query selector body, oops, come on. How about, try that again. All right, so I've got the body there. Well, what properties does body have? Children. Hey, what do you know? And then it has a bunch of children. It looks like an array. So, all right, the style tag. Does that have children? Hey, what do you know? That has children too. Same thing. So let's take a while and just look at this code that I wrote and kind of wrap our heads around it. Just that. That is 100% of the code for like my very limited tree. The rest of it's just data.
So you created two functions here, one which establishes the node, and the second one which establishes the node relationship that how this has gone down.
Almost. First part's accurate. Second thing adds a child. Like all it really does is push something into that array. Strictly speaking, I don't even really need that. I could comment it out. And for these instead, do like ken.children.push, Kyle. These are the exact same thing.
So the second function just pushes the relationship into your array made into establishing.
Bingo.
And for all of our establishing node functions can have an empty array and just a good practice.
Like, you'll probably never write one of these. You'll just use ones that have been made for you, like the DOM. You generally don't, like, I don't know, never say never. Like, you might do something like this, but this is a standard data structure. So even if you were doing something like this, like, you'd use somebody's library for it. Like Java, it's a built-in data type. And so you just use however they implemented it. So this is how it looks under the hood. Like, you don't write that part in practice almost ever.
So like, think of it like the tree, like the circle, like lines coming down.
That's not
really how it works.
No, that's our mental model for how it works. And we can navigate these trees this way. We can think of this as like Ken and Kyle and Karen and Duncan and Miles. Like, we think of it this way and we can access it that way. Like, I don't know why one of these erasers is so much slower than the other ones. So we can think of it this way, and we can like navigate it this way, where you go Ken's children, Kyle's children, but it's all just beeps and boops in the computer ultimately. So you'd program that more like this. This is also why, if you think of those questions where I was like, what is a node aware of? The answer is really, it's children. That's it. Because of that. Now, in practice, like, there's a lot of utilities that people will put in these that, like, keep a reference to their parent. Like, for example, in this node, this has a parent node like reference in it. That's not part of the tree data structure though. That's a convenience thing. Because the rest of the time, how you would figure out who Kyle's dad is you would look through all of the like parent nodes and figure out who has Kyle as a child. You do that the other way around. Otherwise, you have two sources of truth. It becomes possible for Ken to have a child Kyle, but Kyle to not have a parent Ken. If you're storing that data in two places, it's easy for those to stop agreeing with each other at some point. So in trees, you pretty much just keep track of your children. Those are your responsibility. You don't have to keep track of your parents. And to answer this, like, can it skip generations? No, and that's why. Which doesn't mean that, like, Ken can find out who his grandchildren are, but he does it through the nodes by going, who are my children? Who are their children? Who are their children? And so on. So do trees pass information down to children? No, not really. They keep references to those children. And like if we want to pass data through there, we can do it through that hierarchy by doing things like, all right, Ken, your second child, so that ends up being a reference to Karen. You can change Karen's name to Karen Lynn or something like that. We can do that, but otherwise each of those nodes is pretty independent.
So since they're independent rather than isolating Ken first and then getting to Karen, you could just isolate Karen.
Correct. Oh yeah, so I already have the Karen node, and so I could just get that and then work with that. That's what query selector does. Query selector is looking at that entire DOM tree and then finding a specific match. So like this tree pattern, we see it throughout programming. Where else did we see it already? Mod 1. CLI trees, exactly. And so instead of all of this, then that turns into like that. And then there's a home directory. I guess it's not really a path. and you have an Etsy directory. And then build like a segment, I guess is what that would be called. And so then, like, if you were making a path to a particular node on that, you might walk down the tree to wherever, like, that node is, and then collect all of these segments, and then join them together with slashes or something. That's how that works. More questions?
On that topic of scope,
Mm-hmm.
it's going to be the case that only the parent can see the child wouldn't be able to look up somewhere in JavaScript.
Not directly. So, like, Kyle doesn't have any knowledge of who Kyle's dad is. Oh, what a sad statement. So Kyle doesn't know who Kyle's dad is. The way that we'd find Kyle's dad is by going up to the root node and then looking down for who has Kyle as a child. So it's kind of indirect. You have to do it backwards.
And
unlike
JavaScript,
where
where
the scoping can work
on
on
a global scale,
the
ancestor
node
node
won't be able to be extruded in grandchildren.
Not directly. Like, it can walk them. It can say this, that. And since those are all like arrays, we can search them also. So, like, we can say ken.children.find, and we're looking for a child with the name of Karen, and then that will evaluate to Karen's node, like that. So if I run that, oops. Oh, it's because I made these again. All right, try that again. Oop, couldn't find it. Ken.children, find the child with a name, capital K. No, that's right. Why would that not be? Okay, so added those children there. Let's take a look at ken.children real quick. Aha! Found it. It's I got to do .person too. Child.person. So like whatever the data that I'm storing in that node is. And there's Karen. Ta-da!
Thank
you.
More questions about trees. We generally don't talk a lot about scope with data structures because it's data. Scope has more to do with behavior, like functions and stuff. Data by itself, scope isn't really a thing.
The only way to access things is to go through the root.
Mm-hmm.
So that means you have to know the root. If you don't know the root, then you're kind of...
Correct. Like the root is the thing that you're storing. Like in the system, you're like, oh, I'm storing this tree. What you're storing is the root of the tree. Now, some of you picked up on like trees being recursive. So like that's also a tree. So I can split something off at any point and like make my own tree out of it. But yeah, when you're saying like, oh, I stored this tree, you stored the root node, and then you can get everything else from that. So can it skip generations? No. Does scoping work the same? Yes. There's nothing special about it. Do trees pass information down to children? Not really. They just have references to them. And then real quick on binary trees. A binary tree is a particular kind of tree that only has, every node either has 0 children, 1 child, or 2 children, and that's it. So they get used for like very particular tasks because since like we're so limited in how many children something can have, we can represent whether or not something goes down a particular branch with a 0 or a 1. So a good example is mazes. All right, do you go left or right? Left. Do you go left or right? Left. It's a dead end. All right, go back up. You go left or right? Right. Cool, you go left or right? Right. It's a dead end. So you go back. Left or right? So that's how you would use something like that to solve a maze. They also get used a lot in searches because you can just make the path to something with just 0s and 1s. It's pretty cool. But those are pretty unusual. Well, not like they're unusual for web developers. Like you'd never work with this stuff directly. And even like trees, like I said, you're not going to make the tree. You're going to work with the tree. And so like DOM, bread and butter stuff for us. We do it all the time. That is a tree data structure, just like file systems are and anything like that. But like you don't have to do any of this like making nodes and creating the implementation for the tree. You generally don't do that. Cool. Any last questions about trees? I'm going to give you one more resource to read at your leisure. Has a more complete overview of what, like the different methods and stuff, how you would implement this stuff. So head over to MaWiki and data structures. There we go. Hey, that looks kind of familiar, right? It's almost like I used a lot of the stuff out of my personal wiki for your curriculum. So there you go. Like syntax is a little bit different, but basically just what we talked about. All right, I'll throw that in Discord, and I declare trees lesson over, study hall begins.